In this video, you will learn how to use the Lambert W function in solving this exponential equation. Y to the power of 5 equal to 9 to the power of y. We are asked to find the value of y. Don't forget to subscribe to my channel and also give this video a thumbs up if you find value in watching this video. Now let's get started. To get started, all we need to do is you'll come to recognize that these two functions don't have the same base, right? So since they don't have the same base, ideologically you'll come to know that the only way to solve this question is by the use of either logarithm or natural logarithm. So what we are going to use is we are going to find the natural log. So if we take the natural log of both sides, the natural log of y to the power of 5 will be equal to the natural log of 9 to the power of y. Good. So that is done. Now, according to the law of logarithm, you will come to realize that if you have the natural log of a to the power of y, this will automatically give you y multiplied by the natural log of a, because the exponent will multiply the main natural logarithm. So if we apply it to that equation, we're going to have our 5 multiplied by the natural log of y to be equal to y multiplied by the natural log of 9. Great. Now, having gotten to this point, the main thing we need to start thinking of is to see how we can reduce this further. Now, to reduce this further, I want to divide both sides by 5y. If I divide both sides by 5y, what's the reason of doing that? The reason of doing that is so as to clear 5 from this angle and so as to clear y from the right hand side. So if I do that, our result is going to be the natural log of y divided by y, right? And that will be equal to the natural log of 9 divided by what? 5. Great. Now, having done this, you've seen that we've gradually started bringing down this equation. Now, I want to do something. I want to work on this denominator on the left hand side. Now, according to some rules in natural exponent, if we have the natural exponent of the natural log of y, do you know that is going to give us the value y? Because this natural exponent will clear the natural log and our result is going to be y. So that means I can replace the value of y with the natural exponent of the natural log of y. That is that. So I'm going to replace that same value with that value in the denominator. So if I do that, I'm going to have that to become the natural log of y divided by the natural exponent of the natural log of y, and this will be equal to the natural log of 9 divided by 5. Great. Now, having arrived at this, what do we do next? Now, what we are going to do next is to simply simplify. Before we simplify further, I will apply some ideology. Now, on this right hand side, we have nothing to do on this right hand side, because this right hand side will be what? Natural log of 9 divided by 5. Now, what will happen to the left hand side? To the left hand side, I can simply see that this same denominator can easily give us the natural log of y, because it is like having 1 divided by the natural exponent of the natural log of y, and you know that will be equal to the natural log of negative the natural exponent of what? Y. Is going to give us that negative value. So that's exactly will give us this multiplied by the negative exponent of the natural log of what? Y. We did not change anything. We only make that proportional. We did not change anything in that equation. So that equation will now simply give us this, the natural log of y multiplied by the natural exponent of the natural log of y, right? And this will be equal to the natural log of 9 divided by 5. Great. Now, what do we see here? What we see here is this value. Now, what I want to do now is I want to make sure that this power in which the natural exponent is carrying is equal to this coefficient multiplying it. And the only way I can do that is to multiply that coefficient with a negative sign. So if I multiply both sides by negative, I'm going to have that equation to now give us negative the natural exponent of y, because they are together. This will be negative the natural log of y, and this will be equal to negative multiplied by the natural log of 9 divided by 5. Great. Now you see, the reason why we did that is so that we can easily apply the Lambert W function. And what does the Lambert W function say? The Lambert W function states that if we have the W function of a value a multiplying the exponent, the natural exponent of a, that this value will be equal to a. So you see, we have the coefficient being same with the what? With the exponent. And that's exactly what we have in this expression. So if we apply that Lambert's rule there, we're going to have that expression to now give us the Lambert of negative the natural logarithm of y multiplied by the exponent of negative natural logarithm of y, and this will be equal to the Lambert of the negative natural logarithm of 9 divided by 5, and that is that. So you see that that expression will now simply give us this, the natural log, the negative of the natural log of y from this expression to be equal to the Lambert, the W function of the negative of the natural logarithm of 9 divided by what? 5. Great. Now let's simplify, because our main aim is to find the value of y. So what do we do from here? Remember, I can simply write this to be minus 1 multiplied by the natural log of y, right? I didn't change anything, and this will be equal to w multiplied by the negative natural log of 9 divided by 5. So this expression can simply give me natural log of y to the power of minus 1, right? And this will be equal to the W function of minus natural log of 9 divided by what? By 5. Great. Now, at this point, we are going to simplify finally. Now, what I want to do is I want to take the natural exponent of the left and the right hand side. The reason why I'll do that is so as to clear the natural logarithm that is found on the left hand side. So if I take the exponent of the natural exponent of in of minus 1, this will give me the natural exponent of the W function of minus natural 9 in of 9 divided by 5. Great. So from the left hand side, you'll come to see that the natural exponent will clear the natural log, and what will I have remaining there? I'll simply have my y to the power of minus 1 to be equal to the natural exponent of the W function of negative natural log of 9 divided by what? by 5. Good. So gradually we are finding the value of y. That's what we are asked to find. So from here we can see that 1 divided by y is equal to the natural exponent of the w function of negative 9 divided by what? By 5. Now to find the value of y, that's what we are asked to look for. We aren't asked to look for the value of the reciprocal of y, we are asked to find the value of y. So to find the value of y, we are simply going to do one thing, and that is to take the reciprocal of both sides. So we take the reciprocal of both sides. This will now be our y. We'll reciprocate both sides. This will now give us our y to be equal to 1 divided by the natural exponent of the w function of negative in of 9 divided by what? By 5. And this sounds to be the solution to that exponential equation. So the solution of the value of y is equal to 1 divided by the natural exponent of the w function of negative natural log of 9 divided by what? By 5. And that is it. So this is the value of y that satisfies that exponential equation that is given to us up here. I know you did enjoy watching this video. Don't forget to give it a thumbs up, share it with friends and colleagues, and kindly remember before you leave this video to subscribe to my channel for more simplified mathematics solutions. Thanks so much for watching, and bye bye for now.